Okay, let's get started. So this test will have basically 3 questions. The first one is asking you to prove that all the series are convergent or divergent with appropriate methods. For the first one, this is a simple one. That's why you only have 2 points. Basically, this is a p-series. So I check the value of p. It should be equal to negative 1/2. Which is greater than -1. Okay. You can leave this p in your answer without specifying what it means, because I will know what it means. Okay, and then I can say so. The series diverges. That's it. 2 lines. Very simple. For the second one, you will need to use the limit form of the comparison test. Check the numerator and the denominator. The numerator has the leading term 2 root n. The denominator has a leading term n squared. So the first thing you need to do is constructing a new series n or 2n to negative 3/2. Where does this come from? It's basically the 2n to negative 3/2 is the quotient of 2 times root n and n squared. You take the quotient of those 2 leading terms, you get this. Of course, n goes from 1 to infinity. Okay, so construct this. That's the first step. And then you take the limit of the quotient of this general terms. You use this, divide by this. Of course, that 2 is not really important. You don't have to write there if you don't want. Take the quotient, and then take the limit. Now you take the quotient and do a little bit of algebra. You see it's equal to n squared. Sorry, it's n squared minus 1/2 n to 2/3, 2 halves, sorry, 3 halves, and divided by n squared minus n plus sine of n. And then when you take the limit, you see that it should be equal to 1. 1 is a positive number. That tells you that if this is convergent, this is convergent. If this is convergent, this is also convergent. Now we know that this is convergent because other than this 2, and the rest part is p series when p is equal to -3/2, and -3/2 is less than -1. So this is convergent, and that one will be convergent. So you can say, since the series we constructed, which is sigma of 2 times n to -3/2, converges the original series, or the series we in the problem. Converges. And survival. Third one. For this one, the easiest way to do it is using the root test. Remember, when n is greater or equal to 1, the base 1/2 minus 1 over 2n is always greater or equal to 0. Okay. Now take the nth root of the general term. And then you take the limit. So be careful, I'm using the limit form of the root test. Now, obviously, it's equal to 1/2 minus 1 over 2n squared. Okay, 2n divided by n, you get 2. Inside the parenthesis, when n goes to infinity, inside the parenthesis has a limit 1/2. Now you take the square, it will have 1/4, which is less than 1. So according to the root test, the series is convergent. Okay, last one. For this one, the easiest way to solve this problem is the ratio test. So again, it is the limited form of the ratio test. To make it clear, I will write an as root n over n factorial, and an plus 1 will be square root of n plus 1 over n plus 1 factorial. So the limit of an plus 1 over an should be square root of n plus 1 over n plus 1 factorial multiplied by n factorial over root n. Now you can switch the denominator and get the limit of root n plus 1 over root n multiplied by n factorial over n plus 1 factorial. Remember, n plus 1 factorial is n factorial times n plus 1. So this is also equal to the limit of square root of n plus 1 over square root of n times 1 over n plus 1. Now, this factor has a limit 1 when n goes to infinity, but this part has a limit 0 when n goes to infinity. So this limit is equal to 0. If 0 is obviously less than 1. So the series is convergent.